Hi there, this is Further Mechanics Circular Motion Lesson 1. So let's start. Uniform circular motion. So if you considered an object moving around a circular path of radius r with constant linear speed v, just like this. So as you can see, as the object rotates around, the velocity vector remains at a tangent to the circle. So the arrows represent the velocity of the object. As the direction is continually changing, so is the velocity. So you'll know that the circumference of a circle is given by 2 pi r. And the time period to complete one circle, the period, we call t. So I'm just going to give you a couple of equations. So the velocity of an object moving in this manner is distance over time, and the distance is the circumference of the circle, 2 pi r, divided by the time period t, which is the time for one full rotation. So v is obviously in meters per second, r is in meters, time period is measured in seconds. So if you want to write that down, then I'm going to give you a different version. Before I remove that, you should know that time period is equal to 1 over the frequency, or frequency is 1 over t, but we'll need that as well. So I'm just going to remove this. So the equation that we've got, the v equals 2 pi over t, if we sub in t equals 1 over f, we end up with another equation for velocity, as v equals 2 pi r times the frequency. So same again, meters per second, meters, frequency is cycles per second, which we use hertz, hz. So if it was a frequency of 1 hertz, that means that it would complete one full cycle all the way around in 1 second. If it was 2 hertz, it would be 2 cycles per second. Let's move on from there. So if you want to pause and have a go at this. The tyre of a car, radius 40 centimeters, rotates with a frequency of 20 hertz. Calculate the period of rotation and b, the linear speed at the tyre's edge. So the period of rotation, time period, is equal to 1 over the frequency. So that's simply 1 over 20, which is 0.05 seconds. So that's the period. And then part B, linear speed at the tyre's edge. So that'll be v equals 2 pi r over t. Or you could do 2 pi rf, either or, doesn't matter. So it'll be 2 pi times the radius, which is 40 centimeters, which is 0.4 meters, divided by the time period, 0.05 seconds. Or you could have times by 20 for v equals 2 pi rf. Regardless, that gives a velocity of 50.3 meters per second. Let's move on. So angular displacement. Angular displacement, or theta, is equal to the angle swept out by from the centre of a circular path. So if an object moved from A to B, the amount of angle that's swept would be the angular displacement. There's an equation that we can use to describe this. So we've got the angle theta, we've got the radius, and we can call this arc length, this bit, we can call that s. So there's an equation. I've only ever seen this used once in an exam question a long time ago. So theta is equal to s over r. If you do maths, you've probably seen this one before. So theta is the angle that's measured in radians. S is arc length measured in meters. Radius is the radius measured in meters. And on the next slide, I'm going to use this equation to show you where the terminology for the radian comes from. So let's have a look at that. So angles in radians. So if we go from, say, this point A all the way round back to point A, then we've gone through 360 degrees for the angle. So let's have a look at this equation. So theta is equal to S over R. So the arc length of a full rotation would be the radius of the circle. So that would give us theta equals 2 pi R, which is the circumference, divided by R. So the full angle is 2 pi radians. And the angle that we've swept through is 360 degrees. So what we can say from that is that 360 degrees is equal to 2 pi radians. So a radian, if you don't already know this, would simply be 360 divided by 2 pi, which is 57.3 degrees. That's where it comes from now, this equation. Right, let's move on. So next one, angular speed. So angular speed is the amount of angle that is swept through in a certain amount of time. So that would simply be change in angle divided by change in time. So omega is in radians per second. The angle will be in radians. Time would be in seconds. You could also write this as omega equals d theta by dt. Same thing. Same units. If you have a data sheet, it's probably on your data sheet, depending on the exam board. So let's move on. And then finally, we need the relationship between angular and linear speed. So this equation is very important. All of these equations that you've got today, I would probably make a list and try and learn them. Learning them, allows you to be faster in an exam, rather than having to look at a data sheet to try and figure out which equation you should use. If you know the equations because you've done lots of practice, you'll be much faster, and you won't be limited by time constraints as much. So the equation for the relationship between angular and linear speed, which is very important, is this. Linear speed is equal to r times omega. So this is really important. So V linear speed is in meters per second. R is radius in meters. And omega is angular speed, which is radians per second. Going to be using that one momentarily. Let's have a look. So with this question, if you want to have a go at it, you don't have to do A then B, you can do B then A. You probably will have to do B then A. So if you want to pause and have a go, and then I'll take you through it. So a hard disk drive, radius 50 millimeters, spins at 7,200 RPM. Calculate. First of all, we're going to do its outer edge linear speed. So earlier on I gave you an equation. So V is equal to, and it was 2 pi RF. And remember, I talked about frequency being the number of cycles per second. So as you can see in the question, we've got 7,200 revolutions per minute. So if we divide that number by 60, that will give us the number of cycles per second, or the frequency, which is 120 hertz. then we can just use V equals 2 pi RF. So V will be equal to 2 pi times the radius, which is 50 millimeters. So that'll be 50 times 10 to the minus 3. Multiplied by the frequency of 120 hertz, which gives us a velocity of 37.7 meters per second. Then we can do part A. We're going to do its angular speed in radians per second. So we've got the equation. V equals r omega. We know V and we know r, so we can get omega. So therefore, omega will be V over r. So we just need to do 37.7 divided by the radius of 50 times 10 to the minus 3 meters. So that gives an angular speed of 754 radians per second. Right, let's move on. Just got some practice questions at the end. So I want you to complete this table. So just pause and complete. Now be careful with the units. The one that I'm not expecting you to get right is this one. Because I've not explicitly told you how to do this. I will explicitly tell you how to do it at the beginning of lesson 2. But I'll just let you have a go at it. If you get it, if you manage to figure it out, then that's excellent. If not, don't worry about it. So if you want to have a go, I'm going to give you the answers in a second. So the first one, using V equals r omega, you'd get 30 radians per second. Second one, you should get 20 meters per second. Third one, 3 meters. Next one, remember to convert the centimeters per second into meters per second. You get 0.12 radians per second. And the last one, if you managed to get it, but don't worry if you didn't, 0.41 meters per second. And I'll be showing you how to do this type of question in the next lesson. So thanks for listening, and I'll see you soon.